Let's now go back to the HR example we explored in the last module. If you remember, we wanted to see the relationship between a bunch of variables and an outcome, namely whether the employee left the company or not. To do so, we built a logistic regression model which performed pretty well on the in-sample data. Where we're going now is to use the model on the employees who are currently still with us to see the probability that they are leaving in order to undertake actions aimed at retaining them. As always, let's set our current working directory to the folder where we have downloaded the original HR dataset that we explored in the last module and the new HR dataset with the additional observations. Once this is done, we run this line to clean up the memory of our current R session, and we're now ready to load both of our datasets with the read.table function. You already know the argument, the header equal true, and the separator equal comma in quotes. So let's load the old dataset, which is the same that we used in the last module, and the new dataset, which contains only the employees who are still currently in the company. Like in the previous video, if you do not remember the dataset from last module, you should spend some time exploring it again with the str and function and with the summary function. Let's go over quickly the new dataset in order to get more familiar with it. There are 1,000 observations in this dataset, and the 6 variables that you already had in the dataset that we used last module, the old dataset. So we have the satisfaction level, the last project evaluation, the number of projects worked on in the last 12 months, the average number of monthly hours, the time spent in the company, and whether or not the employee had a newborn within the last 12 months. If we now run the summary function on data new, what do we find out? First, we find out that about 20% of our employees had a newborn within the last 12 months. So that might be something that we want to keep in mind when designing employees' perks or working on employees' well-being. Then we find out that on average, our employees worked 100.2 hours per month and that they have spent on average a little bit over 3 years in the company. Let's now rebuild the logistic regression model that we built in the last module. You remember that in order to do so, we use the GLM function, and our first argument is dependent variable, which here is the left variable, then tilde, and then the dot indicates that we want all the other variables to be used as independent variables. We then set the family argument equal to binomial, and in parentheses, logits, and the data that we want to use in order to build a model and compute the coefficients is the original dataset, which is data old. We already assessed that the model was performing well, so we can move on to using it to make predictions for out-of-sample data. Like in the previous example, we're going to use the predict function, and again, our first argument is the model that we called logreg. The second is the new data that we want to use the model on, and in our case it's data new, and then the type of predictions that we want to make, and in our case we set it equal to response in quotes. Now that we have stored the output of the predict function in proba2leave, let's call proba2leave in order to see the output. What we see is that for each of our 1,000 observations, we get a probability. Let's now organize the output nicely in a data frame by using the data.frame function on proba2leave, and we store the output in pred attrition. Let's see the data frame by using the view function. Now we get the same thing but in a nice table, which will be easier to use. Let's go back to the script. At this point, we can use the information in a lot of different ways, but let's focus, like you did in class, on using it to prioritize our efforts to our best performance. So the first thing that we want to do is to add the performance variable to our pre-attrition data frame. To do so, you can type pre-attrition $performance and you set it equal to data new $LPE, which is the last project evaluation and a fairly good measure of performance. Now let's view the output with the view function. You can see now that for the first observation, there's a probability and a performance. Let's now go back to our script. We can build a plot with the performance on the vertical axis and the attrition probability on the horizontal axis. This is what we get. If we wanted to make the output more visual, we could add vertical and horizontal lines with the AB line function like we did before, and maybe add some text labels using the text function. And this is what I'm going to do with the code that I'm going to copy paste here. You can explore the code here on your own, but essentially we can see here very visually that these are the employees that we want to retain. Their likelihood to leave is fairly high, that is the probability to leave, and their performance level is also pretty high. So we definitely want to target our actions to these people. Now, can you think of a way of prioritizing among those employees in a much easier way? As explained in class, we could establish a priority score by multiplying performance and the probability to leave for each employee. So we can add a priority column, like you see here, to our pre-attrition data frame. And the priority would be the multiplication of the performance for each of the employees, each observation, and their probability to leave. Let's run the line. Now if we view the output with the view function, this is what we get. For each observation, we have their probability to leave, their performance, and then their score, which is the result of the multiplication of the probability to leave and the performance. Now let's turn back to our script in order to make our work a little bit easier. What we can do is to order the output in decreasing order. And you can do that using the order function and setting the decreasing argument equal to true. So what we're doing here is that we're ordering from the employee with the highest priority score to the one with the lowest priority score, because we're ordering by priority scores. Now to do so, we create a new data frame called order pre-attrition, and we run the line that we just explained here. The order pre-attrition data frame contained all the data from pre-attrition, but they're organized in decreasing order of the priority scores thanks to the call to the order function. Now let's check out the output with the view function called on the order pre-attrition data frame. And now we see that the employee with the highest priority is ranked first. So based on our resources, we'll be able to decide which employees we want to target our efforts on in this order. Maybe it'll be the first 2, maybe the first 5, maybe the first 20, depending on the company and the resource that we have. But this gives us a really nice way to prioritize our efforts. So that's it for this example, and I will see you in the next video.